They just go so quick. So, all right, today we are hitting the last topic. Um, Hopefully you watched the video. So when I come to this spot, I need speaker, I need this, and I say this guy right here is a digraph, a directed graph. You're going, yeah, I got the idea. I have nodes. I have arrows coming out of the nodes. So, if I'm starting to think, what's this digraph? How would I store this? I'm thinking I would need a struct with the node name, in this case, something as simple as A, but it could have one, two, three, four, five different, five different places. Well, no, wait a minute. It could go back to itself. And we saw that in a couple instances. For example, C could come back to itself. So I might need six pointers to go along with this. How am I going to develop to work with this type of concept? And it fits right in with what we've been talking about. So I'm looking at this now and saying, well, no, wait a minute. Every new data type that we learned, we looked at it one of two ways. We looked at it as a matrix and how we could do work as a matrix. And I had said to draw the picture, draw the picture, draw the picture. But we could store this as a matrix. And in this case, it would have to be what size?
5 by 5.
5 by 5. 1, 2, 3, 4, 5. I think we're
No,
going to have to
no.
go six. Yeah,
Yeah, right.
we're going to have to go six. We need A, B, C, D. Goodness gracious, why'd you make up such a big one? Up through F, and then A, B, C, D, E, and F. And I'm thinking about this as a matrix. We've been working with one-dimensional arrays. Now we're just switching over to two-dimensional arrays. And I start to fill this in. And I fill it in with zeros and ones. And you're going through filling it up with zeros and ones. Does A go to A? Nope. In fact, when I'm looking at this, A goes to C and D. A goes to C, A goes to D. The rest of these would be ones. And this is a way for me to store in this digraph, are the nodes connected or not? And of course, you could keep going. B goes to A, C, and E. B goes to A, C, and E. And I'm going through and I'm actually finding paths of length 1 for this graph. C goes to E and itself. C goes to E and itself. Now, as you can see in this instance, you're getting a lot of zeros in here. Could be worse, but I'm starting to get a lot of zeros. D goes to E, and that's it. So yeah, there's boy, 4 zeros here, except I'm missing one. There it is. E goes to F. E goes to F, D, and B. E goes to F, D, and B. And again, if I count up these ones, that should match the number of edges that I have for this graph. And F goes to E and D. That was the adjacency matrix. Now, in our world, and matrix, there's a lot of places where matrices become extremely important. And one of the things you have to be able to do is learn how to multiply matrices. Should have been done used to be done in college algebra. They took it out. Used to be done in pre-calc. Don't know if it's still there or not. Haven't taught it in a while. But I have this nice representation of what this graph would look like. Now, if I multiplied it by itself, right? If I took the matrix and multiplied it by the matrix, what would I have? What would my representation be? It would be the same size, A through F, A through F. But what would that give me?
Whether a path from one node to another is possible.
Um, a little more than that. This guy is going to give me paths of length 2. For example, from E to itself, there is a path of length 2. There's at least one. I could go to F and then come right back. Here would be another one. I could go to B and come right back. So my E to E, there would be a number in there, and that number would be 2. And if you need more detail, you know where to find it. But multiplying one matrix against another would be paths of length 2. For example, can I get from A to E? Well, not directly. So when you start thinking about this like airplanes, I can get there by going to C and then to E. That would be a path of length 2. Are there any others from A to E? No. What about from, yeah, oh, yeah, there is. Here's the second one. You could fly to D and then fly to E. So these numbers would possibly be 0, 1, 2, 3. Couldn't these numbers would change looking at my representation of ways to get from one airport to another in thought. Again, you know where there's more detail. Questions? Questions. Do 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 do. Okay. Yeah. If you ever want to get into a study in a field of math that has a lot of unknowns, that's this whole graph theory. Okay. Adjacency list matrix. Oh boy. Wait a minute. We've always done arrays. We're thinking about it as a two-dimensional array. That's fine. Or we did work in terms of connecting with linked list kind of representation, adjacency. Oh, what comes into play here? C word. C word. I know you know it. No? Okay. Chaining. Chaining comes into play. So this adjacency list representation, again, you're going to have to do these on the final. How would I do it? Well, I could have an array, and at location 1, I might have this is A, and I have a pointer to what does A connect to? Well, A connects to C, and A connects to D. So I might have something that looks like that, and then this guy would go to null, and we did some chaining things. A sub 2 could be a pointer, or actually we should say 0, right? I don't know, we could do whatever we want. A sub 2 is B, and this is a pointer to, let's see, a pointer to A, a pointer to C, and a pointer to E. So I could store these as a linked list. Now, can I do much beyond this? Not really. This is the good way to work with this data type, dealing with a direct graph. Okay. So in our world, whenever we learn a new data type, we talked about inserting, what could I could insert a new node, I could insert new edges. So I have that whole talk about the insert. I could delete, I could get rid of F, and then anything that F went to or was connected to F. Um, Oh, traverse was another one. And this one's not so easy to traverse. Why, you might ask? Somebody ask why.
Why?
Why is because we don't have a place to start. We don't have a route. We don't have, a top. Where do you want to start? Yeah, I see your point. We could start almost anywhere. Some of you are, hopefully, a couple of you are going, yeah, we can do a breadth traversal or a depth traversal. Well, let's flip the page. Here's a new one. I'll give you a couple of seconds to write this down, and then we'll start to take a look at traversing through this. All right. It's just all over the place. Okay. So where would you like, what node would you like to start at? Go on. Participation sport today, folks. G. Okay. So we're going to start at G and say, where can I get to from G by doing depth first? Well, I'm going to do a little quickie here of here's G, and G goes to just E. E, where does E go? E goes to H and okay. So what I'm actually trying to do here is I'm trying to take a look at a picture, and let's not use G just because that's not a very good one. Let me do this quick example because it doesn't sound like many watch the videos, but let's create a temporary one. I'm going to go something like A here, B is here, E is here, C is here. We're just going around the horn, and D is here. I'm going to connect them. Let's see. Keeping it simple. A goes to C, A goes to B, A goes to E, B to C, and C to B. This is one I've used before. C goes to D, and D goes to itself. So with this depth first, I'm going to do this example. I'm going to start with A, and depth is like a depth charge. You drop it and you keep going until you can't. Then what do you mean? Well, first of all, let's take a look at this as a tree. And as a tree, I might have something along the lines of A goes to B, A goes to C, A goes to E. Let's see, B goes to C. We kind of already have that. What else do we have? C goes to B. C goes to D, and the E is there. So in depth first, I'm going to get ready and say, I'd like to start at A, and I go deep. A goes to B, and it doesn't go anywhere else that's new. A goes to C, keep depth charging, to D, and nowhere else. A goes to E, and nowhere else. Okay, so I'm going to do like a depth charge. I'm going to go as far as I can. So if I come back up here and let's I know it's let's start with A. Now, give me a traversal. Where does A go? Pick any spot.
B.
B, okay. Can I keep going to another unique spot?
Yeah. C.
From B, where else can I go?
E.
From B, I can go to E. From E, where can I go?
G,
To G.
or
And can I,
actually H. H would keep the line going a little bit longer.
well, either one goes to H. Then where does H go?
G.
G,
G.
G. Oh, I hear B. Let's go. Well, we already were at B. So when a traversal, I'm going to go through and be checking my list and make sure I haven't already visited those because I want to see how many I can visit by going depth first. Okay. So I just went to H and somebody said B, but we were already there. Somebody said G, which is good. Now that I'm in G, am I done? It goes to E, which I've already been to, and that's it. So G is done. Now I go back to H. Does H go anywhere else other than G that I haven't been to? Well, that goes to B, but I've already been there. Then I'm going to back up to E. Does E go anywhere that I haven't been to? E goes to H, E goes to G, so I'm done with that. Then I back up to B. Does B go anywhere new?
C.
It goes to C. Does C go anywhere new?
An F under your
It
pencil?
goes to F. Does F go anywhere new?
No.
Nope. F goes to E and that's it. So now F's done. I come back to C. Does C go anywhere else other than F that is new? No.
No.
So I go there and then I back up. I already did these. So you see how I'm doing these check marks. I'm like, okay, good, good. Then I go back to B. Does B go anywhere else that I haven't been to? B goes to C, B goes to E. That's done. I go back to A. Oh, and A hits D, D hits C, D hits F. So that's done. Go back to A. That's done. Okay, so that's a depth first traversal. I start at the top and I go all the way down like a depth charge. Now, breadth is instead of going all the way down, I'm going to go wides and then go from there with more wides. So I would go A, B, C, E, because they're one path away, and then D, because that would be the second path away. So if I'm doing a breadth search, where would you like to start? Something different.
C,
C, okay. Where does C go?
E. 3.
It goes to E. Where else does C go to?
F.
F. Anywhere else?
B.
B. Okay. So you notice these are all one path away. Now I'm starting to design two away. So where does E go to? And it should be unique. E goes to
H.
H
And G.
and G. And I think that's it, right? So
Yeah.
we're good with E. Does F go anywhere? One path away. That we haven't been to. I don't think so. Goes to E, but we were already there. Does B go anywhere that we haven't already been to? E goes to C and E. We have those. Okay. Now I move over to this was one away. When I start on this group, I'm going to be two away. This group is going to be two away. Does H go anywhere that I haven't been to already? I think we're good. Does G go anywhere that we haven't been to already? I think we're good. We are done. We checked all of these off. C can never get where? C can never get to A. And what else can't C get to?
D.
I think D. Yeah. No A or no D. Again, is this the absolute correct answer? No, you could have gone C, B, E, F for that first one away. That's the thing. It's not an exact. There's going to be several different answers that are correct. Just like here, I could have gone a different direction. Could have started with an initial node different than A. Questions? Do you want to do another one? Carl says yes. All right, Carl. Let's see what we got. Corinne says yes. All right. Pick one. Well, we're going to do depth first. Depth. Pick a starting spot. Anywhere.
C.
C. Okay. Go ahead and do it by depth. Then do it by breadth. All starting at C. And I am going to pause. All right, somebody shoot me their answer for depth. Don't be shy. Send it in the chat if you want. What do we got? Depth. Starting at C. C, B, F, I, H, D. F, I, H, D. All right, let's check it out. C can go to B can go to F can go to I can go to H, and then we backtrack. So I goes to H and we stop. We went back to I, can't go anywhere else. We went back to F. It can go to G. G can go to C and B. We already have those. So after F, I stopped. Let's see. I go back to B. It doesn't go anywhere. I go back to C. It doesn't go anywhere. That looks pretty good. Yeah, I can't get to A. What else can't I get to? E. I can't get to E because I couldn't get to A. I like it. I like it. There's another solution. 2, 4, 6, 8. Now, no matter what people throw up, you're going to be able to hit the same number. So 2, 4, 6, 7. Everybody should only be able to hit 7 of them. Can never get to A and you can never get to E. Daniel's was 2, 4, 6, 7 of them. Yeah, cool. All right, somebody want to tell me what you want? Somebody want to show me something with the breadth? So show me what you want, what you really, really want. I'll tell you what you want, what you really, really want. I wanna. Sorry. Slim is here. All right, Slim. That leaves Manu. Manu decided not to come on this last day. Brett. C can get to B, and C can get to D. Those both are one away. CDB, okay, good. There's a solution. And then, so if I rearrange this, that's fine. We can follow Daniel's answer. Oh, where'd it go? C, D, D, H. Yeah. C, D, H, B, F, G, and I. Let's take a look at his answer and see what we got. Let me clear that out. C goes to B. Yep. And C goes to D. What? Did I mess something up? Let me look at Daniel's answer again. C, D, B, H, F, I, G. All right, so let me go back. Thank goodness I'm doing this in pencil. C goes to D and C goes to B. And they are both one away. Okay. Now, next would be, where does B go to? Let's see, B goes to F, and that's about it. Where does D go to? D goes to C or D goes to H. So these are two away. All right, so now I'm going to check here. Where does F go? F goes to G. F goes to I. Okay, where does H go? H doesn't go anywhere. So working backwards, took care of H, took care of F. I already did D and B. Now I come out and I am three away. Does G go anywhere unique? To B and to C, no. Does I go anywhere unique? To H, but we already have that. So this gives me a path of three when I want to traverse. So I can get from C to G my shortest path. Shortest path is a path of three. So C to G would be C to, how would I get there? C to B to F to G. Shortest path is three. From C to I, the shortest path is three. 1, 2, 3. So by doing this Brett search, brings this idea up of something called the shortest path. That's kind of cool. There was an example in the book. You want to check it out. Hope you noticed that I had to fix it because it was actually wrong. But from A, I can get to B, D, and E. These are my path of length 1. From B, where can I get to? From D, from E. It looks like from B I can get to F. And that's about it. From D, it looks like I can get to C and H. You notice how I keep checking these off. So any new ones here, F, because I have B, D, and E, F, C, and H, there's C, there's F, and there's H, are two paths away. Now I would jump to the next group. It looks like, yeah, I can bring into play a couple of new ones. But yeah, here's a 3, and here's a 3. To get to I is 3. To get to G would be 3. So from A to G, it takes 3. 1, 2, 3. And that would be the shortest path. This is just a different way to look at it than what we had just done. we just came up with the list of numbers, A, B, C, A, B, D, E, F, C, H. And then we said, this is 1 away, this is 2 away. G, oh, G is on here, is 3 away. Is that correct? I don't even see a G. Oh, yeah, there it is. There's G. It's 3 away. 1, 2, 3. Questions? Okay. So that whole thing right there, we get into, it's the shortest path. So when I come back to the home, we already talked about making sure you fill this out and email it to me. We've already talked about some of these you're not going to be able to do on the computer. Do it on a piece of paper and upload it in the Dropbox as soon as you finish the test Monday. And the last thing is this traveling salesman. So I want you to go and download Code Samples Chapter 16. Download it. I want to open it up. You cannot minimize Zoom. Oh, okay. I want to open it up. Oh my, where is it? This would be a good time to clean up my downloads. And sure. And when I share, I see, yeah, there's some stuff going on here. This is, again, these are from the NIOP book. You can see that up top, 2005. So these have been around a while, but the concepts are what we're figuring out. Digraph class template. Boy, we got quite a bit probably going on in there. It's a template. We've got the idea of templates, but I'm glad I didn't have to code this. Look at that. Oy vey. Shortest paths in the network. This is what we're going to take a look at. And we have us a program, and I come down here and I see I have to read from in file. And let's go take a look at what the in file is. So yeah, there's the shortest path in the network and graph class and graph connectedness. Where is the data file? The data file is in the book that's going to go along with this. So you're going to do this shortest path program, and give me 1 second to come up with the page number. Just going to make one up. Stop sharing, come back over here, and I would help if I had the NIOP book out. Sorry, folks. Thought I was ready for the day. Here it is. So here is the data file. So I'm in the NIOP book, and we have this shortest path in a network kind of program that's on that I gave you. But here is all of the cities that I'm going to be traveling from. Now, from Los Angeles, this is the data file, you'll see that you can get to 3 different cities. The cities are number 3, which I numbered them for you. The third one is Denver. Number 4, it can get to Chicago. And number 6, it can get to New York. Okay. San Francisco can get to 3 cities. Boston can get to 2 cities. Number 4, which is Chicago, and number 6, which is New York. Miami can get to 8, 3, and 5. That's New Orleans, Denver, and Boston. So if we got ready and drew that picture and started to connect them, I have the following cities. Oh, well, let's start with a very bad drawing of, oh, Florida is now a tip, some of it washed away, of the U.S. That looks like some kind of bad seal or something. I don't know what that is. And we have LA, that's out here. We have San Francisco, that's out there. Again, we're drawing the picture. We have Denver, that looks like Delaware to me. Chicago, CHI, that's good. Boston, up here, Boston, beat up on my Sixers, but the Flyers won. We have New York, which is going to be over here, going to Miami, and New Orleans. So those are my cities. Now I said Los Angeles goes to Denver. Los Angeles goes to Chicago and New York. Ooh. And I could keep going. That just is annoying. We just dropped. I thought we were going to pick up Puerto Rico, but we didn't. San Fran goes to LA, Denver, and Chicago. San Fran goes to LA, to Denver, and Chicago. Again, page 907 in the book is where I'm getting this from. And I could keep going. You got the idea of what's going on? I cheated. If it was all said and done, it might look something like that. Well, that whole idea of Texas is huge. That's what it would kind of look like. And this representation kind of looks like the adjacency matrix. 1 would go to 3, then to 4, then to 6. 2 would go to 1, then to 2, then to 3, then to 4. 3 would go to 1, 2, and 3. Right? So if I was drawing the adjacency matrix, it might look something like, yeah, 3 to 4 to 6 from LA. Trying to tie all this together. Well, I have some notes here, blah, 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 blah. And let's see, what would be the best way to find my notes? Represent this. Well, that adjacency matrix would probably be pretty nice. The adjacency matrix. I would have to remember what my cities were, like LA being one. So I would go down the side, LASF, Denver, Chicago, da da da, and then across the top, and then do my ones and zeros and go from there. Then I would multiply that to so forth and so forth and so forth and so forth. Then I could write a program to say, hey, what is the shortest path? Well, we're not going to write that because that would take a long time. You are going to go download that program, create a data file that looks like this, and run the program. And then you're going to be able to enter what city would you like to start at? What city would you like to start at? For example, I would like to start at, I don't know, pick a city. Somebody pick a city.
New York,
New York. And I would like to go where? Pick another city.
New Orleans,
New Orleans. My question to you is, what's the shortest path? So load up that program, make this a data file in your groups. And when you get it, give me a call. And then we will be done not only for the day, but for the semester.